have systems over there, you will say I'm doing, but we're gonna start now. Alright. So I don't remember the last time we did a meetup for Elixir. I think it was probably like 2 months ago. So I think it's obvious that since Elixir community is big, small, so it's a bit harder to get people get together, and there's not a lot of people who are willing to host this kind of meetup. But after this meetup, if you think like something like this is useful and you want to share it with the team, then feel free to approach me, and maybe we can go to your company next time instead of face. Like every meetup has to be a face, so it's not very interesting anymore, right? Alright, so today we are very lucky to have a guest speaker, Steve Wagner from Seattle. So I'm not going to waste your time, so I think I'm going to pass the baton to you now. Alright.
I think I have this up before.
I'm not sure in terms of how to project event.
Well, this is not it.
So if you can just, in this case, just plug it in here, we'll actually be recording, but I'm not sure how you cast. You have to show how to cast.
Should probably check this earlier.
Yeah, casting, right? Yeah, you can cast. Hey, Brent. Yeah, I think you can introduce yourself. Right?
Okay. So, hi, I'm Steve Wagner, and thank you for that introduction. I am visiting from Seattle, Washington. I work with a company called Avo. At Avo, we work with attorneys and their customers. So the idea is, if you have a legal problem, you come to our site and you can search for it. We have a big question and answer section. So if you ask a question, chances are an attorney is going to answer it for you. We also have tools and such for attorneys so that they can engage with their customers as well through email, through phone calls, and advertising. I am on the attorney side of things. We have a consumer side and an attorney side. So my main focus is on the tools for the attorneys. I had been there for 18 months now, and at the time we had an issue come up where we have a certain way of serving ads. So it's a way of figuring out if somebody wants to advertise something, we'll have multiple attorneys in a market. A market is a combination of a geographical area and a practice area. So criminal defense in Los Angeles, animal bites in somewhere Idaho or whatever. So we take that and we have attorneys in those areas who want to do advertising. So we'll kind of figure out how many people are in that market. And so we have to figure out how to serve these ads. And we had a legacy way of doing it, so we would charge certain amounts. We would kind of value that market ourselves and say, okay, we think the market is worth this, so we have this many impressions in that market, so that means that per impression costs this much. And then the attorneys could buy into that market. We delivered against that. It had some issues with it. So they came along and said, okay, we want to try out different ad models, different ways of figuring out these ad ways and how to invite them.
How do I get out?
How do you know that?
It's the wrong. It's easier if you do mirroring.
You want to do this? So after I joined, I was asked to join a special team that they put together to look at different ad models. So I've got a lot of ad serving experience. So we'd come up with a couple of different plans to do with different ways, and we created these tests to do. So we would implement something and put it out there and see how it worked. Is it possible to screen test that also? Yeah. Okay. Start. So we've got to skip through some of this here. So this is the introduction. Over this. And so in order to do all this stuff, we have 5 basic services that run to get this done. For security reasons, I've kind of renamed stuff, but we have an ad server that sits out there, and its main goal is to take requests from the internet and say, hey, I want some ads for this market. And it will go through and figure out what those ads are and return that. It can return it in a JSON format, or in some cases it returns actual HTML that we inject into our web pages. The second one is an ad model manager. So once we decided we wanted to run different tests against these ad models, we had to inject this thing in the middle of it. So that is an Elixir service that's pretty straightforward, but it understands that if it gets a request for a specific market, it's going to go to a certain subsystem to get the ad weights for that market. Then we have the legacy ad model service, which is the way we've been doing it for a long time now. It sits on top of HBase and Stargate. So HBase is a big distributed database, all that. Stargate is kind of a RESTful interface in front of that. Then the test that we went with the longest is the SOV ad model service. SOV is just, it's a really, really simple way of doing things. So it's a bidding system. And if you have 10 advertisers in a market, and each of them is willing to pay $10, then each of them gets a 10th of the impression. So if we have 1,000 impressions, each of them gets 100 impressions each. So this is one of the things we wanted to try out. So this is kind of a diagram of the system, pretty straightforward stuff, all RESTful interfaces. And back in May, we had a disastrous event happen. We lost HBase, and we had no backups, and we could not figure out what was going on. And what happened here is with the ad model manager service, this has a cache in it. So as it was reading from all of the HBase stuff, it had it in memory, so it kind of keep peeking along. Over time, though, about a week after this happened, we realized we are not going to recover HBase at all. It's going to take months before we can do this. And we're hoping, against hope, that the ad model manager service doesn't crash, because it's the only thing that has these ad weights in it. And even so, even if it stayed up, as time goes by, all those ad weights are stale. So we're not getting the feedback loop in there saying, we've served this many, so we need to update those weights. All that's being lost right now. So a couple of us got together and decided we could create a stopgap measure, and we called this project Atlantis. Atlantis itself is an Elixir service running in Phoenix, simple REST interface. It just mimics what's going on with all the other components so that it was seamless to inject this into the overall system. And it basically served as a cache for the ad weights, same as the HBase stuff did. We were going through, we ended up using ETS, or laying term storage, to actually store the data in this. The process we went through, we're trying to figure this out, is, well, what's the best deal for storing this data in the back end? So mostly we use MySQL databases. We have some Postgres in play now, so we consider that one. The problem we had with that was that it's just too slow. We're talking, thousands of ads a second, tens of thousands of ads per second that we have to respond to with these weights. And we just couldn't get it to be performant enough. We looked at Redis because, hey, this is going to be fast. The problem with Redis became actually loading the data into it. So we've got some pretty large data requirements going into this stuff. And what we found was, when we used this for the cache, it would respond very quickly, but when we were loading stuff into it, it literally took hours to load our data because it's trying to write the disk behind the scenes. And we ended up, it ran for 6 or 7 hours, and we finally just killed the process because it can't take this long. It's not practical at all. We looked at just writing a custom cache implementation, but just don't do it. There's no need to do it, right? If you can find something out there, there's no need to write your own custom cache. Unless you have a really weird requirement, there's no need to write the cache. So when we looked at ETS, it's like, okay, this actually provides most of the stuff we need. I don't know how widely known ETS is, but there's a really nice write-up on elixirschool.com. It's all in memory. It's built on OTP, so it's in the runtime. You don't have to have any external libraries, any external servers or anything running. You can store lots and lots of data in this thing. And for us, the most important aspect was the constant time access to the database. A table in OTP is owned by a process. So process spins up, you create your table, and if that process dies or you kill it, your data's gone. It terminates that table as well. So there's a reference here that goes into much more detail than a slide can. So we need to have high availability on this, right? Because we're, again, serving tens of thousands of ads per second. One way we dealt with that was we run multiple instances of this service, but we also had our data team want to be able to update these weights whenever. We kind of went back and forth on the interval of that. What we ended up doing was using Quantum Library, and every 2 hours, it goes off and looks for a file in a specific place, loads that up, and populates the cache for that. Obviously, we're using Gen server, so we keep these processes long running. The loads, we got them down to just a few seconds for a few million rows of data. So the file they give us is just a CSV file, and it's pretty simple. I think there's 3 columns in it. It's an ad market, a weight, and then an ID. And so with this, we were able to refresh this cache very quickly. And so kind of just a quick look at the code for this. Did this show up? Do you know how I get this to broadcast this as well?
It's not customized. Should I go?
Yeah. We'll go back there, or do I?
Share the desktop. Easier.
Share the desktop.
It's great sharing the desktop.
Oh, do I need to stop the slides?
It's close to the desktop. Chromecast desktop. Laggy, but it's right. You need a custom the desktop.
Basically, what we did is that we had 2 Gen servers running, and just a simple API endpoint that has 2 functions in it. There's an index that's used for actually searching, so they give us the criteria. We go on to the Gen server and looks it up in ETS to make sure the results back. The other endpoint is a create endpoint, so if you hit that, it goes in and starts loading this cache. It starts off and loads the file from where we're storing it. It parses through that file and it calls back to our AdWeights Gen server to create that cache. And so the AdWeights server itself has 2 tables in it. So when it spins, the Gen server spins up, it creates 2 tables in ETS. So up here in the init method, so in Bigin.
Big is not enough, it needs to be
Huge,
huge.
okay.
Yeah, it's okay.
This work? So it's pretty straightforward stuff, right? You're creating new tables. Interestingly, when you create a new table in ETS, you can give it doesn't care about the name so much. So we give it the 2 tables the same names. You're returned a PID value for that. And so then this just goes into the state of the Gen server. So when a lookup call comes in, it's passing in the 2 tables. We're always going to look in the first table for a lookup. This is the active table. And so it does this lookup and returns the stuff back to it. The interesting part comes when we go to load this from the CSV. It jumps in, and we've got just a high-level method to do that. And so it goes and it gets the file. Is this big enough? Bigger? Okay.
All right.
So we retrieve the file, and then we hydrate the offline cache, which again, it just parses through there, it extracts the data out of it, and update cache. Update cache calls back over to the AdWeights Gen server. And so where'd store go? Store, there it is. So this just calls an insert. So again, we've got the 2 tables coming in the state. This guy, we don't care about the active table. We want the secondary table, so we're only pulling that one out. And so we do the ETS insert into the backup table. So as this is spinning through all the records, it's pumping it over into the backup file. And it gets to the end of this, and everything's happy. It says apply waits. So apply waits turns around and calls apply waits over here. It first has to delete the active table, all the records from it, so it clears it out. And then it changes out to the table. So it returns the next table as the active table and puts the active table as the next. So we've effectively done kind of an atomic swap of that cache file. And so when we built this, we always knew that we wanted to go back to the HBase Stargate implementation. Our data team wasn't quite sure how long it was going to take. So again, this happened in May. We put this in place. It took us a day to several days to figure out what was going on, what we were going to do. But once we decided, a day kind of exploring all the different options and whatnot. And we had the service up and running in 2 days and out in production. So we were able to rest easy that if the other thing crashed, it was okay because we had this backup. It was actually only about 2 weeks ago that we shut Atlantis down. Our data team was finally getting it all back together and put everything back at the HBase. So this thing was a stopgap measure for several months for us. It was super fast to do. The response times for the queries on this thing were 7 to 12 milliseconds against this cache. So we were astounded ourselves at how quick this thing was. It was very, very resilient to everything we could throw at it. So this kind of goes to the name, and the title of this talk is Atlantis, How Not to Sink. When we came up with the name, we were talking about, it's like, well, yeah, this is going away, and we're trying to keep ourselves afloat right now while all this stuff goes on. So we called it Atlantis, and Atlantis finally sunk at the bottom of the ocean a couple of weeks ago. So that's the weird title of this talk. So to kind of wrap up here, ETS is an amazing thing. Obviously, with anything, there are trade-offs. It's very fast, and it's very fast. And it's really easy to use. The biggest downside is if your process crashes, you lose all your data. So you kind of need to have a plan for that. In our case, it didn't matter because we could load it back up so quickly, and we had multiple instances running that we were okay with that. It didn't hurt us. So to conclude, I'd like to thank everybody for allowing me to show up and crash a party here and talk about this stuff. It's been great. A big shout out to Rapid River and the folks there. This is my first time out of the United States, actually, and it's been a wonderful experience. Great team. We've had a lot of fun, and I have not eaten so much food in a very long time. So it's all very good. And lastly, to our team at AVO, the infrastructure team, who has done so much work over the past several years to make this so that we can deploy this stuff quickly. We have the ability to spin up a service and deploy it into production the same day because of all the work that they've done. And it's full logging support, it connects up with PagerDuty, so if something goes wrong, we're automatically alerted. It's just an astounding bit of work.
All right, so I think we're gonna have like 5 minutes for questions.
Oh, I'm sorry.
Yeah. If you guys have any questions for Steve, what's the runtime memory like?
So it's been a while since I actually played with this. We had close to 1 gigabyte of data going in there, and it was rock solid at just over that. So it was enough for the process itself, and just over a gig, maybe 2 gigs. And we'd watch the charts, and it didn't care at all. So there was concern at first that, oh, this is going to roll over, but it stayed really steady. The answer?
One gig for both data sets, the active and the next?
Yeah, but so when it loaded, so that short time during the actual load, both of them were in memory, but once it did the swap, it wiped out the original one. So it reclaimed that space very quickly.
So did you were you running this on a single server or is it like distributed?
So we have we're using Rancher. Familiar with this? So Rancher is a Docker orchestration tool. And this is what I was getting at with our infrastructure team. They had taken Rancher, and I could go in there at any time and say, you know what, I need a production environment to run some tests against it. So we say, create this environment. And it goes off, and it uses Docker Hub and pulls all these services down and deploys them into the EC2, in the cloud. So this is kind of the same thing. We were able to just say, deploy this with Rancher, and I want you to have 4 instances. It would go through and say, okay, well, I've got space on this server, I've got space on this server, and it would actually spin up 4 Docker containers. It may be on the same server, but most likely it's not. So it was actually across actual physical parts.
So they're probably not sharing the same state, right?
Right, not at all. Yeah, because with that stage with the process itself, even if you had two of these services running on the same box with different containers, they would be isolated. If one crashed, the other one's going to be okay.
You can have EGS distributed on the nodes, but then I think you need to handle it. I don't remember.
Yeah, there's some way you have to join the Erlang runtime.
Nodes and then, but I don't remember the details.
Elixir?
Oh, okay.
Yeah, so there's this like Erlang native that you can use. It's called Elixir.
Okay.
Yeah. So when you connect nodes together, you can have Elixir to basically share the ATS.
Is that an eventual consistency thing? Or
Yeah,
is,
yeah.
Okay, so you could still be out of sync maybe?
Yeah.
I think for our, we're still at 5. Yeah.
Is there any limitation on the amount of data that you can store?
During part of this, there are really 3 pieces of data we are watching. There is a fourth definition, and it's an arbitrary length string. And so in our initial test, we were including that. And not only was there the size of the data, but there was also explosion of data. They don't get the vectors in that data. So I think the original CSV they gave was 75 gigs. And obviously Redis didn't handle that at all. This handled it, but it still taking a very long time to load. So we convinced them to do away with that. And once we went back to the HBase stuff, they could put that back to it. So there is a constraint, but we were it worked for us really well. I don't have an actual physical number to say. Anyone? Going once? Twice? Sold. Thank you.
All right, thank you, Steve. It was a very good talk. So I remember last time we had a meetup, and one of the complaints was we are always talking about Ruby versus Elixir or PHP versus Elixir. Yeah. So yeah, we kind of have to move out of that circle because I think Elixir has its own strength and its own weakness as well. So I think we should focus on what is about Elixir that we should be talking about instead of what are the strength or weakness of other languages that we're trying to fix, right? So getting to my talk, so the topic today is AMQP with RabbitMQ and Elixir. Okay. Right. So I'm not going to assume that everybody knows what is AMQP, but AMQP has been around for quite a while and has been used for a lot of applications where you need to have sort of like decoupled applications, right? So I'm going to give you a little bit of introduction about AMQP and RabbitMQ. So what is AMQP? It stands for Advanced Message Queuing Protocol. It was established in London by John O'Hara, 2003. So it's been a while. But the stable version was released just in 2011. So maximize this. Of course, casting. Okay. Maximize your screen, please. The browser window. Yeah. Alright. Okay. So this looks awesome. Yeah. So it's been there even though for a while, but it's old. But I think it's still gold because a lot of companies are still using that. And what is RabbitMQ? So I have a link over there if you wanna find out what is RabbitMQ. So it's just a 5 minutes introduction of what is RabbitMQ. It explains very well about RabbitMQ, but just on a very high level. This project was started in 2007. It was backed by enterprise, so they were not being. It's open source from day one, but it's being backed by enterprises. So you can kind of like appreciate that because the development was very stable and consistent. If you compare with other open source projects, and it supports multiple messaging protocol. AMQP is one of them, but they have a few others: Storm, MQTT, and also HTTP. So if you're thinking of using RabbitMQ in your applications, you're not limited to just AMQP. You can also use HTTP, especially like if you're using language like synchronous, like PHP or Ruby. There's always an option using HTTP. But RabbitMQ is famously used as AMQP client. It's built on LLM. And some of the use cases that we use RabbitMQ is for buffering. So when you're sending email, usually in Ruby, you would send it to some kind of queuing system like Sidekick, right? So you can use, basically you can use RabbitMQ for the same purpose. So if you have like long running processes, you can set a queue to RabbitMQ. It's built for resiliency, so it's being backed by ETS, and you also have amnesia. So when something fails, it will like recover itself, restart itself, and then you're not going to lose your data. Basically, for scalability, if you're using a lot of processing powers, so let's say like you're doing something with your data, but you want to have a few services to do something with this data, right? So you're going to have like a few servers doing different things. So that's where RabbitMQ can be used for. You can use it for decoupling your system. So if you have a lot of components in your applications, you want to try to break it down to smaller components, and you can use RabbitMQ for that. And it's also for real time, because most of the comparisons between for RabbitMQ, people will compare it with SNS and SQS, right? So one of the major advantage of using RabbitMQ is because it's very low latency. So you can have like almost real-time application with RabbitMQ, right? So any question on RabbitMQ? No? Okay. Right. So let's go a bit detail about the flow when you're using services or applications like RabbitMQ. Right. So in the base of it, you have the producer. So you can imagine that this is probably your application. So maybe like someone clicks. You have an application, you have a user. A user clicks on this button, and when the user clicks this button, you want to do something like sending an email or writing data to your database, right? So we call that the producer. Right? So producer is basically like it produces events, and then this event will be sent to RabbitMQ. So inside the RabbitMQ, you have a few things in there. You have the exchange, and you have the queue, and you have also what we call the routes. So we call this component as the broker, and the last part of this is your consumer, which is the application that's going to process the queue. So the AMQP protocol have a few types of how they handle the data, right? So we have three types of flow. Basically, we have what we call the direct exchange. We have what we call the topic exchange, and we also have the fan out exchange. So I'm gonna like go through one by one very quickly. So the first one is direct exchange. So what is direct exchange? Basically, when you have a producer, you send a data to what we call the exchange, and this exchange will write directly to your queue, right? So, for example, if you have a binding key called PDF create, so if you're going to see that, then when you send an event to the exchange, it sends directly to this key.
And when you have an event for PDF log, send directly to this queue. So that's what we call direct,
because you have to specify directly which queue do you want to send this event to. The second type of exchange is the topic exchange, and this is a bit more complicated than the direct one, because now you have this the dot notated queue. Right? So for example, if I have a queue, I have a few queues called agreements.eu and agreements.b and then agreements.something, right? So I can send to this exchange by agreements.asterisk, and then it will try to send out to all of this queues. But I can also like do some sort of very simple pattern matching using like maybe agreements.b, so it will only send to the queues with agreements.b.something. So yeah. And the last one, which is what most people would use it for, is the fan out exchange. So in the fan out exchange, you only care about the exchange, right? So if you have a sport news exchange and you want this exchange to send to the all queues, when you send to it, and this is what you will use. So imagine that if I write data to database, and for this event, I want to make sure that this data has been logged, and I send an email, and then another one probably like I call a service to track interaction of this user. So I just call this one exchange, and it will call all of these three queues. Right. So I hope that's clear. But of course, you can go to the YouTube link that I have in the slide later if you want to understand a bit more. Right. So let's talk a little bit about this library that I'm using in Elixir to implement AMQP protocol. Yeah. So this is called AMQP. It's called Elixir. It's basically just a wrapper for AMQP client and Rapid Common. So both of this library is being developed and by the RabbitMQ developers themselves. So it's pretty stable. So far, I have not run into any major problem with that. And then, so far, the way I'm using it, I get to understand like a few situations where how this thing might break, and a few gotchas that I learned is when you're using MQP, you should always run it as a gen server or maybe like a gen stage or something, that it must be supervised so that when it dies, you can restart it, right? So you don't want the process to die, because when the process dies, then the queue will accumulate and probably like you're gonna have a lot of queues not being processed. So connection can and will die. So there are situations where maybe like things like network partitions, or maybe like your server is going down, your network is going down, things like that kills the connection. So your application must be able to handle that. Otherwise, it will crash the whole system. And then if you're using the producer-consumer patterns, meaning that if you have one gen server to spawn many consumers or workers, you will have to make sure that you are handling any errors in your worker on a separate process. You don't want to handle that in your own worker, because if this worker dies by brutal kill or something, then the queue will not be processed, and you're going to have accumulated of queue as well. And another thing is you don't need to use gen state, right? Because the first thing that when people talk about queue, people ask things like, why are you not using gen state, right? Because gen state is basically perfect for doing queue system, right? But you know, there are applications where you can use gen states, but for RabbitMQ, you don't really need to use gen states, because most of the benefits of using gen states, like back pressure or spawning the workers, is already there in your gen server and RabbitMQ. All right, so I'm gonna share a bit of codes, if you guys don't mind. How do I?
Yeah, just maximize the screen. Sorry? Just maximize the window. Let's see what's there. Oh no, you need to cast the. Are you casting the desktop?
Okay.
Thanks, screen share. Yeah.
Okay.
One more.
You guys can see this? Should be bigger. Okay. Yeah. Alright. So this is basically just a module that uses Gen server. It acts as the consumer. So what it does basically, it connects to RabbitMQ via AMQP protocol, and then RabbitMQ will push messages to this module. Right? So we can actually set the amount of messages that we want to receive by this parameter, prefetch count. So in this case, I'm going to fetch only 100 at a time. So when I receive 100 messages, what I'm going to do is I'm going to spawn 100 processes to handle this, right? So what happens here? Basically, I connect to Rabbit, and when I connected to the Rabbit, I will get the channel, and I'm gonna monitor this channel using this process.monitor, so that if something happens that it goes down, I would handle this here. So when the connection dies, I would immediately call connect again, so that it reconnects. And then I'm gonna set my prefetch count, and I'm gonna start to consume the messages. Right? So in this flow, whenever I get the messages, it will be handled by this function, basic deliver. So basic deliver is part of the MQP Elixir parameters that they give to us, right? So I'm gonna grab the data. I will make sure that I get the delivery tag, so that I can either confirm or reject this message later on. I want to make sure that this message was not re-delivered, because sometimes you get a message and then it dies or something, and then you don't want to like handle that again, right? So you just want to like either put it in another queue or just ignore it. And then the actual payload. And then this is the callback that you give to RabbitMQ, basically to act on NAT. So act is a short for acknowledge, and NAT is a short for not acknowledge. So what acknowledge does, basically, when you get a queue, you want to tell back to the RabbitMQ that I have received this message, I have processed it, so you can like remove it. But not acknowledge is you want to remove it, or either like please requeue it, please put it on another queue or something. And this is the part where I actually spawn other my workers. So my worker is actually another Gen server process. And remember when I said that you want to probably manage your process, your worker process on separate Gen server. So I have a separate Gen server called manager for that as well. So let's look at the worker. So worker in this example is just a simple Gen server. So when it gets a process, it will just do some logging or something. I will try to track the exit so that in situations where it might die, I know what's happening to it. But the manager itself is the one that makes sure that when I give the PID of the worker, I will monitor this process, and if it goes down, which is here, I will call the acknowledge function. Right. So that's pretty much my presentation. You guys have any questions? Oh shit.
Switch.
Okay. That's the danger of live streaming.
Don't want for that. I hope. Anyway,
It's okay. It's our death, so it should be okay. Right. So any questions you guys have?
why would anyone use RabbitMQ over, say, hosted Amazon service like SQS or what's the other one?
SNS?
SNS, yes.
Yeah. So that's a question I've been running into as well. I think.
Against what?
Can you repeat the question?
AWS and AWS's SQS and SNS, which combined together would be able to deliver some of the things that RabbitMQ does.
Yep. Do you want me to repeat that question? No? No? Okay. So one of the questions that I always run into when deciding between SPS and S, between RabbitMQ or some other services, most of the time people question that because they're worried about managing the service, managing a RabbitMQ service. So I'm sure that's debatable. I've been listening to this podcast. So the creator of RabbitMQ was saying something like 90% of the problems usually because of network partition. So if you are actually on EC2, you can kind of prevent that from happening. But in our case, we are not betting on that. So we are using Cloud AAMQP. So it's a managed hosted service. It's a bit more expensive than SPS. But if you consider the flexibility and the features that RabbitMQ has over SNS and SPS, I think it's worth it.
I'm not familiar with AWS service. What are the features that you have?
Basically, if you're talking about routing, so routing in RabbitMQ is very, very flexible. So remember we talked about SNGs, you have direct topic and fan out. So you can kind of really control the flow of your data. But if you're trying to do something like that on SPS, you kind of have to work around the limitations. And also because of things like latency, so SPS is a bit slower in this respect. Whereas if you want to do something real time, RabbitMQ is probably a better
You're using an external service.
Sorry?
You're using an external hosted
Yeah.
Right?
Yeah.
Is that still faster than?
Yeah, it is. It's also very expensive if you compare to SPS.
Just now you mentioned about you don't have to use gen stage, but because the terminology just now you the producer and then the worker and consumer is do something similar like gen stage.
Yeah.
So NS is how it works also similar like gen stage.
Yeah.
So when do you decide to go out with this you or
Right. Yeah, so I think one of the main reasons why you would want to use GenStage is, for example, you have a large amount of processes, large amount of data that you want to process. So you want to be able to have some sort of a back pressure. So maybe you have 1,000 data, but you only want to process 100 at a time, right? So you are going to use GenStage for that. But in our case, if you are using RabbitMQ, since you have the prefetch, right? So RabbitMQ will always make sure that you only get 100 messages at a time. And only until you process all of them, it will send you back another 100. Right? So that's exactly what GenStage is already doing. So, well, you don't need GenStage again, right? So what you're going to do, like you get 100 messages and then you want to like have another batch creation. It's kind of redundant.
But it's in the same app, but it's not actually separate.
So I think one use case that you might want to use GenStage for this is, for example, your application have a few consumers in itself. So in our case, we only have one consumer. Right? So imagine that you have a few more consumers, but you only have one client to the broker, the RabbitMQ. So let's say you get 1,000 messages, but you want to make sure that each of them is not processing more than what the process can handle. So that's where GenStage might make sense. But if you only have one consumer in the application, I don't think you should use it.
At what point does it fetch the next batch of 100 from when you acknowledge 100, or say it fetches when you acknowledge one, and then it fetches another one, fill the
So I would say I'm not sure so much, because so far when I was running this thing, it was like very quick, 100 processes in mere microsecond. But I would imagine that as soon as you acknowledge the message, it will send you a new one. So as long as you are still within the refresh count, it will send you more and more.
So actually it meant is the 100.
Yeah.
If I may, when I was using RabbitMQ, it's only after you finish your batch that you actually get new stuff.
Okay. Yeah, I didn't know that. Like I said.
It might have changed. It was some time ago.
Okay.
It might have changed.
Is the order preserved, like the number of jobs?
First in, first out, right? Yeah. So that's another feature of RabbitMQ that SQS is struggling with. So in SQS, you have first in, first out queue, but there were some kind of limitations to first in, first out queue, because, for example, when your messages was processed, then it dies, that queue gets sent to the back of the queue instead of like the front of to the original position. But with RabbitMQ, gets sent back to the original position. So yeah. So if first in, first out is important to your application, RabbitMQ should be like a better service for that. Any more questions? No? All right. So thank you so much. You can like remove that stream, right?
You can edit it, don't worry.
You can edit.
But anything that's live is...
Oh, man. First time, sorry. Alright, so we're gonna have another talk by Imran here about Distillery 3.0.
Don't worry, you had fun today, changing all this.
Never open that.
Should I connect this, or should I?
Connect. Because I'm recording directly.
And then cast, right?
Cast the entire desktop again.
Okay. I should hide the secrets. Okay.
Just don't have any secrets open.
Hello everyone. My name is Imran. I'm currently working in Fave as a engineer on the web team. So I'm going to give a talk about Distillery.
Any of you know about distillery? Okay, most of you don't, right? Okay. So I'm gonna explain a bit. The painful point of starting out in Elixir is actually deployment. Deployment is really hard. So before 2.0 came out, distillery was the good. No, even before that, there's something called XRM, which is the go-to, I guess, release package that you can use to release your Elixir and chuck it into a server and start it up. But the problem with that is that all your configurations has to be available during compile time. So whatever you build at that moment, that's going to be a configuration. You can't really configure it at the runtime. So they've so after XRM, the author started writing Distillery 1.0. That solves a bit of the problem, but there's still some issues. So Distillery 2.0 aims to solve a bunch of these issues. I'm going to highlight them. Okay. So in 2.0, they started introducing something called config providers. It is basically it's just an Elixir module that you use. It has this function called init. So you can actually source your config from multiple providers. I guess you can maybe chuck in, use JSON as your provider or etcd as a provider, any source. So, but the default provider that comes built in with the Distillery 2.0 is the mix config provider. So this solution obsoletes the previous workarounds that everybody uses, like replace OS vars, which basically scans the config and replaces environment variables that are enclosed in percentage curly braces. And then there's also that system-env call. It obsoletes all of this. Okay, so so how do you use it in 2.0? So in 2.0 they have this new construct called config provider. You just it's a stack that you can put. Basically, whatever is below it will override the one before it. So let's say you compile your app. It includes all the configurations that you have during compile time, and then you introduce another layer of configuration, which is config provider. This will override whatever you have during compile time, right? So here I'm setting config provider and then a template, a config template that you can use to include as part of the release. Okay, so a typical runtime config that will look like something like this. So you fetch a few things from the data, from the environment variables to fill in the application configuration. For example, this is one for Ecto and one for Phoenix endpoint. So in 1.0, this has to happen during compile time. But in 2.0, whenever your app boots up, it would fetch it from the environment variable and make it part of the runtime config. Okay. Another interesting thing that arrived in 2.0 is hardcode upgrade, but way more simplified. So in 1.0, when you want to do a hardcode upgrade, you'd have to place the app apps in the right folder. If you use edeliver, then you don't have to do this, it's automated. But then in 1.0, if you want to do this manually, you have to generate your app apps. App apps are basically instructions for the application that's running on how to upgrade to the next version. Okay, so in 2.0, this is all automated. It basically scans for your previous build and then finds a pair and generates the app up automatically and place it in the right folder when you extract it. So if it doesn't find a pair, it does a normal release. Okay. So this is how a typical release looks like. You run mix release to environment prod, and then it would go through all the thing that it does, and then it generates all the release in the rel directory. But then when you want to do an upgrade, you would do something like this in a single command. You just run mix release upgrade. So wait, before you run that, right? You start your app and then it's running in production. and then you want to make an upgrade release, you run this command, it generates an app up here from 0.1.0 to 0.2.0, and then what you would do then, you just run this in the server, and it would run the app up instruction to replace the modules that it needs to replace. So on top of this, there's also they call it app up transformer. So sometimes you might have additional things that you want to do on top of the default instructions that are generated. Maybe you want to delete all your Gen server modules and reload them just so, or maybe you don't want to do anything. So app up transforms helps with that. I think this is extreme use case. I don't think like a normal app would use this, but it's there if you want to use it. So they also updated documentations extensively. If you see here, the new one includes a lot of guidelines on how to deploy to AWS, how to deploy to DigitalOcean, deploying with Docker, upgrades and downgrades, and all the shenanigans. All right. So I'm going to show a bit of a demo on hardcode upgrade. Okay. I've got a repo here that I've worked on. Okay. Okay. Good enough. Right. So let me just share you the release config. So it's really simple. You just run release init, then it would give you a default config, and you can maybe add config providers. So you can even throw in your own config provider. For example, you have one called etcd. As long as it implements the behavior init function, then it would work. You just need to check out the correct format. And then you have templates of the config that it would try to copy into the release. So it's just nothing in here. Okay. And then yeah, that's it. It's just that. Okay. So let me just try and run a release. All right. Bigger. Okay. Okay, so run a release. So pre-compose all the front-end assets, and then digest it, and then assemble a release. Oh shit! Sorry. Let's start with 0.1. Okay, I'm gonna just delete my build. Okay, so I'm currently at 0.1. Okay, and I'm gonna run a release. Right. So you're going to get an archive that you can deploy then to your server. So I'm just going to run it here in the locally. So I'm going to run next here. Okay, it says here like I don't have a bunch of config that I should have provided. So in 1.0 you would have to actually bake those into the when you run the release, right? But in 2.0, what you can do then is you can go into the build directory and go into the release, and you have the templates that you copied just now available here. Okay, so I'm just gonna configure this app. So this also helps you, like let's say you have multiple environments, right? You can just use different config for different environments. Okay, and then I'm just gonna copy this. Right, okay, and hopefully that works. Oops, wait. Okay. Okay, now it's running. So if I go to 4000 and I open my app, now it's running, and I have a Phoenix channels running in the background. Basically, it's a WebSocket connection that just outputs a counter that counts +1 indefinitely. Alright? So here, I'm going to run an upgrade that actually changes the count to be a 2 step without actually taking down the connection right now. Okay? So meaning, like, let's say you have an ETS table with all your data load up, and you don't want to lose that data during upgrade, right? If you use a normal release, you replace an instance with another instance, those data are gone. But with upgrade, then it stays there. Okay. So I'm gonna check out hit. Okay, now I'm at V2. If I see my version now is in V2. Okay, now I'm gonna run an upgrade release. Oops. Okay, release, upgrade. Not sure if this works. Yeah, you always need to. I mean, you can actually use like so semantic version is a requirement. You can append it with what do you call it? Commit SHA or something like. So it would scan the build directory for previous versions that you've built, and then tries to find a pair. If it finds a pair, then it generates an app up for you to run the upgrade. Oh, looks like it's not working. Alright, okay, generated an app up. So on the right side, you see the server running. On the left side, I'm actually building the next version. And after it finishes, I'm going to deploy it to the server without taking it down. Okay, but before I deploy to the server, I'm going to share with you what I actually changed in version 2. Okay, so this is the channel that the user join when they visit the homepage. I basically just increased the bit count to 2. Okay, so the step is going to be like 71 to 73. Okay, now I'm going to run the upgrade. So here I have the next version 0.2. Okay, so I'm just going to copy this, drop it here, upgrade to 0.2.0. Okay, enter. Hopefully it works. Alright. Cool. So you see this stepper now runs at 2. So you didn't take down your server, all your state retains, but you've managed to change your code. So that's the Siri 2.0, guys.
Any questions for Brett?
Would it work if your system is distributed? How does that work?
Yeah, so if your system is distributed, you need to send your archive to all the servers and run the upgrade. Because the upgrade happens on the server itself. It runs the app up instruction and tries to replace all the modules.
So I remember there is this promise about Siri 2.0. Basically, you no longer have to build your release on the same environment as your production server. So has that promise been delivered?
No, so cross compilation is not there yet. If you want to build your release and deploy to another server of a different architecture, for example, one way to achieve that now is to not deploy with what do you call it? ERTS. So have ERTS installed on your server, then your release will generate without ERTS. So it doesn't try to use to include ERTS in the release. It will just run using whatever is on the server. Yeah. So ERTS is basically the runtime, Erlang runtime. A release includes everything it needs to start. You don't have to install anything on the server. Everything is packaged up. Yep. Anything else?
Do you see this something that can be run from Ansible, for example?
We're currently migrating towards this 2.0. Right now, our infra team is using Ansible to actually configure the config file. So populate it with all the details needed for a specific environment. Before this, what they would do is they configure the build server. Now you can practically run your build anywhere, and just a different config for each environment. So one artifact, deploy anywhere. Previously, you have to build artifact for each environment. Okay, that's all. Thank you, everyone. Just speak this out.
Yeah.
All right.
Okay.
So usually we do open mic sessions for anyone to share. Any last thing, last minute thing you want to share, yes. Or maybe you want to shout out for hiring or anything like that. Are you hiring? Yeah, are you hiring? Anything? Yeah.
Hey everybody, so I'm Callum, I'm from Rapid River. We are a small consultancy, dev shop based in KL. We do web application development with Ruby on Rails. We do some data engineering work. That's the kind of areas we specialize in. Some of our people, a team is working with Steve here on the Apple project. We're doing various things there, a lot of Rails, but also I believe we will be working with their team to do Elixir work here and there as needs arise. So if you are interested in potentially at least working with Elixir in production, if you are also experienced with Rails, you like working in a place that has a remote first work environment, flexible working hours, then check us out. Talk to me about opportunities. I'm here, I'm around. So yeah, thank you.
All right. So we also have Faith. Faith is hiring. I'm looking for Faith. We're hiring a lot of people. We just got funded. You're not in the circle. We're like 20 million. Maybe I can just talk about Faith a bit. We are pretty much language agnostic. We don't care what background you have. If you're a PHP developer, Go, Java, C#, whatever, right? We don't care, because we believe that you can actually solve problems in one language, but there is specific language that is best to solve a specific problem. So we actually, we encourage people to be diverse and to learn new things and want to learn from each other as well. So if Faith is something that sounds interesting for you, go to careers.myfaith.com and you can apply that, or you can just meet me after this. You can forward your resume. And also, there's also another startup which I'm also working for. It's called Naluri. Yeah, so we are hiring Elixir and React.js or React Native developer. So the React Native part is very interesting. And we need more people, we need more manpower to bring us to the next level. Yeah. So you can also meet me after this if you're interested. Alright guys, anything else from you? Yeah. Okay.
So on behalf of the company I work for, Sell Media, we do marketing, mobile and stuff. As you can see, if you're interested, we are looking to hire experienced Elixir developer because that's the company is interested to move to migrate to Elixir. So we are looking for experienced Elixir developers to lead and maybe coach and teach the existing teams. So if you're interested, just leave me or any other candidates around here. Thanks.
Okay, so I think that concludes our meetup today. Thank you everyone for coming. I think we have a very inspiring turnout today. I didn't expect we had wow, how many of them? 100? Yeah. So this is a good crowd. So I hope we're gonna meet for